Section 8.5 is adding and subtracting rational expressions. You know, if we were going to multiply and divide, now we're going to add and subtract. And then also at the end, we're going to sneak in some complex fractions just to make life difficult, don't you know? All right, remember that when we are adding and subtracting, we have to have like denominators. The denominator is your bottom number, so here we go. 7 over 4x plus 3 over 4x, we can immediately see, oh, well, this is actually quite simple because they have the same denominators. If the denominators are the same, just multiply the numerators and then keep your denominator. And this is just like back in 6th or 5th or whatever grade you learned how to add fractions. You just have variables in there now. So 7 plus 3 is 10 over 4x. And then remember, once you get to the end, you need to check to see, can you reduce? And 4 is 2 times 2, and 10 is 2 times 5, so your 2's will reduce. So you have 5 over 2x. The same thing happens with binomials. These binomials are the same, so we're going to add. If you can't combine like terms, if they're not like terms, then you just put them beside each other. 2x minus 5 over x plus 6. And you're done. Don't be tempted, once again, don't be tempted to reduce these 2's or these x's because this is all part of a binomial. In order to reduce, the whole binomial has to be able to reduce. All right, so what happens if you have fractions that don't have a common denominator? Well, you need to find a least common denominator. So your first section in your homework is simply going to be adding fractions with like denominators. Easy sneezy, don't forget to reduce at the end. Then you're going to have a section where you need to find the least common denominator. If these were the two denominators of your fractions, what is the least common denominator? So I have some handy dandy little steps for you. In order to find a least common denominator, first you're going to write the prime factors of each denominator. And then once you have all of the prime factors, you're going to use one of each of the different factors that are involved. All right, now that's different from greatest common factor because that was the biggest one that was in common. Now the least common denominator is going to be, it's got to include every one of the factors that are involved. I'll show you what I mean in just a minute. And then after you get all those factors, you multiply them together and that's your least common denominator. So here we go. Here's our two denominators we're talking about. So step one is to factor them. So 4 will come out of each of these. So x squared minus 4. And then this will actually factor smaller. So 4 is x plus 2 and x minus 2. And don't forget that the 4 is 2 times 2. With this one, 6 will come out of here, leaving x squared minus 4x plus 4. And then this can reduce further to x minus 4. Oh, there's two of them, so x minus 4 squared. And we can just put x minus 4, however you wish. All right, so now to find the least common denominator, what I like to do is I like to take those factors and line them up. And I didn't give myself enough space, so I'm going to kind of use this space here. This one is, let's just do this one first. We've got 6 is 2 times 3, and then we've got x minus 4 and x minus 4. All right, so these are all the factors of this denominator. This denominator is 2 times 2. It doesn't match the 3, so you can't put it right under the 3. So 2 times 2 times x plus 2. Oh, guess what I just did? Okay, this is good to know. I was like, well, this should match. Guess what? 4 times 4 is not 4. And you probably are hollering at the screen right now saying, what are you doing? 2. There you go. 2 times 2 is 4, and 2 plus 2 is 4. Now we're matching better. And now we can put the 2's in here, and now things will match. Okay, good deal. All right. Now are you together with me now that I am together? All right, so now when we put the x plus 2, x minus 2, and x minus 2 matches this one, the x plus 2 does not, and like I said, I don't have enough room. So now what we do is, to find the least common denominator, we're going to take one of each of the different ones. So we need a 2 and another 2, but look, these match. We've got a matching, we don't have to take it twice. All right, we're just going to take one of those, and we need a 3 because we don't have a 3. Oh, look, I tell you what, I'm just a basket case today. A 3 is what I said, so that's what we'll write. The x minus 2's we're just going to take one of these because those match. So, but they matched in the different denominators, so we just need one of them. But this one we have another x minus 2, so we got to keep this, and we got to keep this x plus 2. So our least common denominator is going to be, least common denominator, when we multiply those all together. So 2 times 2 is 4, 4 times 3 is 12. And then I'm going to put the x plus 2 first, and then x minus 2 quantity squared. So that's what I mean by, so first you write out all the prime factors, then you want one of each of the different factors. You don't have to have this one twice because it's already represented in this group of factors. You don't have to use it twice. So that's why I line them up so that you take one of each of the different factors in order to find your LCD. Okay, let's add some fractions. So once you find your LCD, then what do you do with it? And I think you know, but let's do it. All right, so 9x squared is 3 times x, and 3x squared, a 3 and an x will come out, and then we have x plus 1. So now when we line these up, we've got 3 and an x matches, but the x plus 1 doesn't. So for my LCD, I'm going to have 3 times x times x times x plus 1. So my LCD now is 9x squared times x plus 1. Do you see where I got that? 3 times x times x times x plus 1. So now this is my denominator, and this is the denominator for both of these fractions. So what we need to do now is we need to make each of these have this denominator. So when I make this be 9x squared times x plus 1, well, in order to get from 9x squared to 9x squared times x plus 1, I had to multiply this denominator by x plus 1. So if I'm going to multiply the denominator, I have to multiply the numerator also. And this had a 3x times x plus 1. So there's a 3x and an x plus 1. So we're missing an x and we're missing a 3. So I'm going to multiply this one by 3x. So did you see what I did? Did you see how I figured out what to multiply my numerator by? Whatever is not in this common denominator needs to be multiplied by the numerator. All right? So then you just multiply through. So we end up with 7x plus 1. Make sure you multiply that through. Plus, and you know what I'm going to do, because this is, I'm just going to change the order. Because this is 3x squared and I want a squared term first, I'm just going to change the order, plus 7x plus 7. And then you can look to see if this will factor out, but it's not going to be able to do that because you got to end up with a 7 in between, and that's not going to work. So this is your final answer, and you're done. All right? So finding that common denominator is a little bit tricky, and then making sure that your factor or your fractions, then your numerators have that same denominator. I'm going to scooch it down again. Okay, so now for this one, if you think you know what you're doing, go ahead. So we've got 2x minus 2. Let's pull out a 2. We've got x minus 1 here. Let's factor this. X and x, same signs. They're going to be negative. 3 and 1 is 4. And so now we've got x minus 1 the same. So this has an x minus 1. So what we've got here is we've got 2 times x minus 1, and we've got x minus 1 times x minus 3. So for your common denominator, you need the 2, you need the x minus 1, and you need the x minus 3. All of that together is your common denominator. So this one already has the 2 and the x minus 1, so it needs an x minus 3. So you're going to multiply the numerator by x minus 3. This already has x minus 1 and x minus 3, so it just needs a 2. And so now you're going to have to multiply through the numerators. Your denominator, remember, is already figured out. So keep it 2x minus 1, and I'm standing right in front of it, x minus 3, or squatting anyway. Here we go. So now you're going to have to use FOIL here. So we've got x squared, and then we've got negative 3x, positive 2x is negative x, and negative 3 times 2 is negative 6, and then minus a negative. What I do is anytime I have a minus, I'm going to change all of these signs. You're going to add the opposite of all of them. Make sure if you're subtracting that your negative sign goes all the way through that whole binomial or it'll mess up little parts. All right, so now multiply your 2 through. So you have plus 4x plus 2. Now you've got to combine like terms. And I did not give myself enough room. Again, oh my word, these problems that take lots of space are super fun, but they make a mess. All right, so now I think what I'm going to do is I'm just going to combine it just right up here for space sake. So I've got the x squared, and then 4x minus 1 is plus 3x, and then negative 6 plus 2 is minus 4. Do you see what I'm doing? I just combined the x's and the constants, and now I'm going to factor to see if I can reduce at all. So I've got x, and my signs are different, and the difference is going to be 3, and I want it to be positive, so positive 4, negative 1, and lo and behold, the x minus 1's cancel, and so my final answer then is x plus 4 over 2 times x minus 3. All right? And now when I stand up, my head will be chopped off. Okay. So it's the reason I'm swinging through this so quickly is because I think you've added and subtracted fractions before. So it's the same type of thing, it's just more complex. And speaking of complex, let's simplify some complex fractions, which you might have already done before. A complex fraction is simply fractions within fractions. And you know, or you should know by now, that a fraction bar simply means divide. So 2 over 3 means 2 divided by 3, and that's how you can change it into a decimal, is just take the top number divided by the bottom number. And that's why, because that division bar is, the fraction bar is a division bar. All right, so we're going to take a problem such as this, 2d over x plus d over y. There are two different ways that you can simplify a complex fraction. The first way, and what I'm going to do is I'm going to show you both ways, and then you can decide which way you prefer. Some types of problems are easier in different instances, so it's good to know both ways. So the first way is to simplify the numerator, simplify the denominator, and then just divide, because this means this divided by that. So 2d is already simplified. If you want to simplify d over x plus d over y, you've got to get a common denominator. And we know we've got an x and a y, so we want this to become xy, so we need to multiply by y. And we want this to become xy, so we need to multiply by x. So now we've got 2d over dy plus dx all over xy. So now we have a simplified, we have just a fraction over a fraction, and this is 2d over 1 would make it a fraction. So let's flip and multiply 2d over 1 times, flip this one because this means 2d divided by this fraction. So we're going to take xy over dy plus dx. So now we just have a multiplication problem. Now it's a simple multiplication problem, as simple fractions instead of a complex fraction. So now reduce this out or factor it out, dy plus x, and you can change it to x plus y just to keep them in alphabetical order. The d's will cancel, and now multiply straight across to get 2xy all over, I'm going to change this just to be alphabetical, x plus y. Ta-da! Simple! All right, let me show you the other type real quick. All right, the other type is to determine what is the common denominator of all the fractions in the entire complex fraction. If you multiply every fraction by that common denominator, it's going to get rid of those, it's going to get rid of those fractions. So what we want to do now is, in this case, this one is actually not so hard because I've got x's and I've got x minus 5. So I'm going to multiply both the top and the bottom by x times x minus 5. And now what I'm doing is I'm multiplying this numerator and this denominator, so I'm still just multiplying by 1, so I haven't changed the value. Now when I do that, I have to multiply each part. So when I multiply this part by x minus 5, then the x minus 5's cancel and I just have 6x. And if I multiply this side by all of this, the x's cancel and I just have x minus 5. Did you see where that came from? So when you multiply this all the way through both parts, so I'm going to do the same thing here. I'm going to multiply this fraction by x minus 5, and I'm going to multiply this fraction by x minus 5. So in this case, the x's cancel, and I end up with 3x minus 15. And I multiplied this 3 through the binomial is where I got that. And then the x minus 5s will cancel, and I just have 2x. Ooh, don't forget this is minus 2x. And now I have a simple fraction instead of a complex fraction. Now you're just going to combine like terms. 6 plus 1 is 7x. So that's going to be 7x minus 5. And this is 3x minus 2x is x minus 15. And once again, be careful, you can't reduce the 5 and the 15 because they're part of a binomial. All right, that was a crazy, quick, fast zoom through complex fractions. I think you've done them before is why I'm zooming quick. So if you haven't done them before and you need me to go back through one or the other of these methods, please feel free to ask me in class. Make sure you write these steps down. Either just take this as 2 separate problems and simplify them down, and then flip the bottom one and multiply. Or find the common denominator of all the fractions and multiply all those fractions by the common denominator, and then you eliminate all the denominators and you end up with just one fraction. Okay? All right, I'll see you next time.